Good morning all, more PCBs. I'm so into making PCBs at the moment, it's just crazy, and in fact I'm kind of doing PCBs rather than anything else at the moment, but I'm enjoying it, so that's all that matters. So here are the printed circuit boards. They are for my analog playground. That's what I'm now calling the vocoder, because it's an analog playground. It's a big array of analog circuitry which you can play with. That's why I'm building this thing. I have no need for a vocoder. Who would need a vocoder in this day and age? So as I say, this is the output mixer. Now the original vocoder project calls this the output amplifier, but it doesn't really amplify much. It's pretty much one-to-one gain, but it is a mixer of multiple signals, and there are lots of signals coming into this mixer. So there's my little board. It has 3 potentiometers. I've called it the output mixer amplifier. Those potentiometers will go through the front panel, and it has 2 dual inline ICs. They're dual op amps, I think, or is one of them a single? I don't know. I'll have to look at that. I have power here on a JST with capacitors, because this is 12 and minus 12 volts, and a ground, of course, in the middle. And there are 3 socket positions here. Now, this is going to be interesting. Have I got this right? Once again, I got 10 of these boards. Don't really need 10. So we'll just work with 1. Now, do you remember these things that I made the other day? These dual, well, in this case, it's a dual stereo mini jack to 8-pin dual inline daughter board. And I also made a quad version and another quad version. Well, this is where they go. So that one goes there. They're quite a tight fit in those holes, which I quite like, actually. Yeah, I quite like that. Now that should have enough clearance to enable the JST to operate normally. Now these, I haven't soldered any dual inline pin arrays in yet, so no, these are still covered in grease. I hope not. Let's snap off some sets of 4 of these things, and then I can see whether I've got my alignment or positioning for all of this lot right. Interesting. I should have got this right. I mean, I kind of worked it all out when I was doing the PCB layout. But let's see. That goes on there. Oh, that's looking pretty good. Incidentally, some people said that these are so close together, I'm going to have problems with the jack plugs all being in very close proximity to each other. Yeah, maybe not. Okay, this one. Oh, that's quite beautiful, actually. Look at the spacings between them. That's a 1/20th of an inch. There's another 1/20th of there. They're raised up slightly because I've got to... Oh, actually, maybe I could do that now. No, that won't work because it'll just... These aren't soldered in. It'll just push them out. But I think that's pretty good. There's a 1/20th, I think, to the edge of the board there. And this board has to be this width. It is defined by the... Well, kind of defined by the spacing between these pots. And it just left a little bit of space there for the JST power. I quite like that. So looking at the vocoder front panel, or should I call it my analog playground? This is a playground. It's a bit like when you were a kid, 5 years old, you went to the playground, you've got swings and a slide and a roundabout and all that sort of thing, and you buzz between them because you can't decide which is the most exciting at any particular moment. That's what this is. This has got amplifiers and mixers and, perhaps more importantly, filters. And filters are such interesting analog components, not components, but elements of circuitry, that this is just going to be an absolute playground for someone who's interested in analog electronics. Right, this, so this is the input amplifier. There's another one of these actually that sits here, but it's for the excitation input, the music input. Let's call it the music input. This is the speech input. This is the music input, and speech modulates music. That's what the vocoder does. Now, right over the other end of the 19-inch front panel, we've got the output amplifier, and that's going to sit there, just above the power switch. And what? Oh, that's the main vocoder output. And in fact, that is going to be a full-size 1/4-inch jack, kind of like this. Let me take this bit off. Kind of like that, but the spacing on these pins isn't correct on VeroBoard. And that will sit under the board, and the pots will sit on the top of the board. And this board sits here, right at the other end of the front panel of the vocoder. So that's where it's going. That's the context. So, would you like to join me today as I construct the, let's say the swings of my analog playground? As I say, this is a mixer. It's not so much an amplifier. In fact, you can see that if I zoom in. Look at the component values. They're pretty much all 22K. There's a 33K there. So the designer of this has gone for a little bit of gain for whatever reason. There's a bunch of pots there which are just volume controls. Oh, there's a single op amp there, 741, and a dual op amp there, 1458. So yeah, join me as I construct one part of my analog playground. Now, I came in for some mild criticism the other day for bothering with the whole component identification thing. I don't think I'll bother today, but I'm going to fit these 22K resistors first, 22K, and I'll fit the 33K. So let's get those all out, get them in the board, solder them on. That's interesting. I'd obviously breadboarded this output mixer or some variant of it because I got some of these 22Ks bent into breadboard shape. I can't remember how many there were of these. I'll just get out a few and we'll get those in first. Now, I've just found that I have a printout of the output amplifier in my Vocoder project box. So here it is. It's just a bunch of op amps, most of them operating at approximately unity gain, but that 33K slightly lifts the gain of this stage. A few pots which are mixing in signals from elsewhere in the vocoder. One there, the input speech bypass. This is the excitation bypass. And then another unity gain stage here to the final output of the vocoder. So that's where you plug that into your amplifier and listen to the wonders that come out of this machine. That's the original PCB from the original article in ETI, Electronics Today International, October 1980. Yes, it's 39 years old. Oh, it's nearly 40, isn't it? No, not 40. It's nearly 39. So let's get assembling this. Now, there is a very interesting part of this, which I will explain as I go along. I just want to point that out. And that's this thing. This thing mixes together a whole bunch of signals from channels 1, 2, 4, 6, 8, 10, 12, 14. And here 3, 5, 7, 9, 11, 13. And you can see that largely this is splitting odd numbered channels into this inverting stage. Even numbered channels, although there is an anomaly there. I'm not quite sure why channel 1 crept in there. Why isn't channel 1 in amongst this lot? That's interesting. Yes, the even numbered go into this, which again is inverting, but this is additional inverting. So these ones get double inverted and these ones get single inverted. And it's something to do with the a filter has a phase shift. Now I'm going to have to get the filter curve shapes to fully explain this. Oh, go on then. Let's do a bit of component identification. Oh gosh, those reds don't show up very well. Let's use this torch. Yes, that's better. Red, red, black is 220, and then red is 0000. So 22000, 22K. That's all the component identification I'm going to do in this video. You'll be pleased to know. So let's do a quick tool rundown. Today I'm using my Rapid solder. It's 6040 tin lead alloy, 500 grams. This was half a kilo of solder. Actually, there's still quite a bit on there. And it's 22 SWG standard wire gauge. None of this American wire gauge nonsense, as Dave would say. And I'm also powering my TS100 from my modified BFG, whatever that is, and a 4 amp hour lithium battery. So it's going to be getting about 20 volts. Actually, I think we can see that. Yeah, 20 volts. Look at that. Now I can't switch it on until that default. Actually, I probably could get that. Oh, there it is. Switch that on, warm that up, and we'll get these resistors soldered in. Incidentally, this solder I once left in the garden for several days, and when I brought it in, it was really cold. You could perhaps describe it as my colder solder. Think about it. And yes, I'm a sponge fanboy, none of this brass shavings nonsense. Right, gratuitous soldering shot. The smoke will come. It'll be very atmospheric. You've always got to have a gratuitous soldering shot. In goes the first of my... That's wobbling around, isn't it? The first of my 22K resistors. And there it is. And it's beautiful. Let's have a gratuitous close-up. Oh, they're a bit flat, aren't they? Not very... mound-like. Yes, they're a bit pancake shaped, aren't they? Let's have some more gratuitous soldering shots. And I've actually got some other solder. This is alpha rosin core solder. This is really old. This was given to me when I first started field service engineering. So it's probably 30-year-old solder. In fact, you could describe this as my older solder. Think about it. Look, it's coming on. I've got 4 of the 22K resistors in there so far. That one not soldered, so let's solder that right now with the older solder. There it goes. Does it feel any different? No, it feels pretty good. Possibly slightly old. I don't know, maybe I'm imagining that. There's a nice little cluster of stuff here actually I thought you'd like to see. We've got a resistor here which extends underneath the outline of this component. Well, that's a potentiometer, and we know that they stand off, so it's not going to be a problem having the resistor under the body of the potentiometer. There's also a dual inline pin array there, and that's because there's going to be a socket, but that's going to be soldered on the underside. So it's a lovely little cluster of components on both sides of the board. Yeah, this 33K here is really quite interesting. Everything else is 22K, so the audio signals from the 2 input amplifiers come through with no gain, but he's got a little bit of gain on all the signals coming through from the vocoder stages. So maybe the vocoder section has a very slight attenuation, and he's put 33K in there just to lift it up a little bit. That's quite interesting, isn't it? So the final resistor is a 33K. Have I got one that's a single? Because I normally cut these into pairs. I don't think I have. So we'll have to take a pair, and let's put all my 22Ks back in here. So 33K, I won't identify it. You know what it's going to be. It's going to be orange something. Well, actually, it's going to be orange, black, red. 33K. In you go. That provides the little lift in gain for the vocoder filter stages. Oh, slightly overbent that, but never mind. It's sitting in there. It's not falling out. Let's use the colder solder. Well, that's all the resistors done. I don't think this board has it. Oh, yes, it does have some capacitors. Oh, they're 1 microfarad. That's interesting because the input amplifier had 22 microfarad caps on it. Yeah, they are 1 microfarad. Directly across the plus 12 volt and minus 12 volt rails with respect to ground. Right. Oh, actually, I think I've got some 1 mics actually sitting on my desk here. There they are. Yes, now I've got to be careful here, haven't I? Because I made the mistake last time of where the hole goes to the ground plane, putting the negative of the capacitor. And that's correct for plus 12 volts, but of course it's the wrong way around for minus 12 volts. Let's see if I can get this right this time. Got a feeling I've standardized on plus 12 volts being pin 1. I think that's what I did. In fact, it's easy enough to check. Pin 1 is the square pin, so that's left. That brings me to right. That comes down here and goes to pin 7 on that chip, and pin 8 on that chip, so that's got to be pause. Let's see if I can get this right. On the positive side, we have the negative leg to the ground plane, that's the short leg. On the negative side, we actually have the positive leg to ground and the negative leg to the more negative voltage, which is this, minus 12 volts. Yes, it goes to pin 4, and yes, it goes to pin 4 on the other chip. That's definitely right. So, in the power supply part of the board, we need a 3-pin JST, and I'm kind of adopting a standard where the latching parts are at the edge of the board. Hopefully, I might have to break that rule at some point, but I hope I don't have to. That's not holding itself in, so a bit of blue tack there. Let's get that soldered in. I do like JSTs for power. They're sort of becoming the ubiquitous power connector now. I mean, in the old days, I'd have probably used Molex or something like that. I suppose I could have used no, I couldn't use a DC power jack, could I? Because I wouldn't have the split power supply. And in fact, the VU boards, do I have one of those? Got one here somewhere. Oh yeah, here it is. I've gone for a 4-pin JST because there is additionally to the 12012, there's also a 5-volt input to this thing, which actually drives the LEDs. It uses the 5 volts to light them up. Got a feeling this chip says if you go over 7 volts, you have to introduce a series resistance, because otherwise the power dissipation in the chip can be too much for it and it can get overheated. Next, I shall use some little single inline turned pin arrays for my dual inline op amps. Obviously I'll need 2 per chip. They're 8 pins, 4 pins in a row. So those are my IC sockets. Let's find the ICs. So I found a 1458. The other one is a 741. I've got a feeling I've got some in here. I'm sure I ordered some a while ago. Now, where are they? Are they under here? I've got a feeling those might be the 741s. So, preempting the comment, oh, you don't want to use 741s. Those are ancient old things, really noisy. Well, I'm building this, in terms of components, relatively true to the original design. I'm going to deviate in a few small ways. The thing about using sockets here is that if I want to do some tests later on to see whether 741s are noisy, I can very easily replace it with something like a TLO 81 and see if the noise level drops. But initially, I want to use all the original components. And back in 1980, I don't think there was a lot of choice in consumer grade op amps. Right, let's get these components in. 1458. Oh, that's wobbly. Blue tack needed. And 741. I probably shouldn't have bent the legs in. I should have left them splayed, and that would have given me a little bit of friction fit, wouldn't it? I really do like the look of old through-hole analog electronics. It just has that sort of gloriously retro look about it. Yeah, I love it. Right, let's find the potentiometers. 10k log, 10k log, 10k log. They're all volume controls, essentially. A, 10k logarithmic. The B taper is linear. The A taper is log. These came from Tader, if you're interested. And I've got more than 3, so that's good. So 3 A10Ks all lined up, ready to go. There's a lot of slop in these, so it looks like, trouble is if I put blue tack under there, I'm going to have a devil of a job getting it back out. No, I'm not. I've got pliers. Blue tack it is. I decided to blue tack and solder one. Oh, this is the ground pin. This is the hardest one to solder because you lose heat. I'll come back to that one actually. Yeah, you lose heat in through the spokes onto the ground plane. Still think you should be able to change the size of the spokes. And yes, I know in other CAD programs, PCB Layout programs, you can. Wow, that really is sucking the heat. I've got to hold that on there for a bit. Okay, that's on. Now, of course, these are quite bendable. Oh, that's pretty good. Got that pretty straight. I'm just wondering, actually, whether I could put this through the front panel to align all the pots. Is that a thing? Now, one of these pots still has its little metal tab, which is a locking tab. You can drill a hole to lock the pot so it doesn't rotate. But these aren't going to rotate anyway because they're all mounted on a board. But anyway, I've just got to break that tab off. It's cast aluminium, so it breaks quite easily. Put that in the board and solder it. So I was wondering if I could kind of put these through the holes, and it's just more trouble than it's worth because everything rotates. Actually, probably wouldn't if I put the third one in, but I'm not sure. No, it's not going to help me. I think I'll just use blue tack. That's the potentiometers done. Do they all line up? Yeah, not bad. What about the shafts? Yes, I think that's pretty good. So what else needs to go on here? The underside mounted mono jack socket. Oh, and I think I've got my jack daughter boards somewhere. And then the daughter boards, which are these ones that I showed earlier with the mini jacks, go on the back here. I've got a feeling that's it. Yes, that is it. So pin array into breadboard. Again, 2 sets of 4 on here. And this is to put the pins on the bottom of my full size 1/4 inch jack daughter board. So let's poke those into the breadboard. Now this one doesn't need any special sliding of the black plastic on these pins because everything's so huge on this. I think that goes on the underside. I didn't do silkscreen on the back on this one because that's before I kind of worked out how to do it. But I'm getting better at PCBs now. I'm really enjoying actually this working with JLC PCB because it means I get to do a lot of PCBs and get quite good at it. I mean, don't get me wrong, I've done a lot of PCBs in my earlier years, but of course it was done differently then. I started off with Dalo pen. I etched all my own boards in ferric chloride and all that sort of stuff. I then moved on because I was working for a typesetting company. I used to lay my boards out using freehand. What was it called originally? Aldous freehand, I think, and then it became Adobe, I think, or Macromedia or something. Used to do it in freehand, which of course isn't a PCB design package, but it's very good at generating all the shapes you need. It was just much more laborious. It's so much easier now. Now I've just remembered I need a fibre washer to slightly move the mono jack back, and I seem to remember, yes, that doesn't quite fit on there. Or does it? Oh, it does actually, just about. Yeah, I think I reamed the other ones out, but yeah, so that should just move the socket back ever so slightly so that it all aligns. Actually, I haven't soldered that in there yet, have I? I need to solder that into my daughter board. Let's do that next. Yeah, it's interesting. These legs on the mono jack socket, 2 of the pins are actually slightly fatter than the other 2, so they're a really tight push fit into the daughter board. The other 2 are quite loose and sloppy, and they also they're not cut very accurately, so this thing doesn't quite seat flat, so it's slightly tipped over at an angle, which is all very annoying for someone with OCD, mild obviously. But that's where this pin array thing actually works really well, because you've got this sliding adjustment, so I can slide that in and out. They're actually quite tight, and that just absorbs any sort of, I don't know, misalignment. So I'll get that soldered, and then I'll put it all on the front panel and get that final alignment, and then solder these pins into these arrays. Yes, that one at the back there is slightly difficult to get to. So here's the super fun bit, and that is mounting this through the 3 holes where it goes, and then also putting that, I'll have to take the nut off, into its hole and getting the up and down alignment, and then soldering a couple of pins. And I'm even going to go to the, I might have to ream that hole out because I think I undersized the holes for the jack, so that might have to be done. Yes, I'm even going to go to the extent of centrally aligning the pots in these holes before I tighten the nuts and washers so that it's all very precise. Yeah, when I had this panel made, I didn't really know the diameter of the thread on these jack sockets, so I underestimated it and it doesn't quite fit. But it doesn't seem to be a problem if you ream out the powder coated holes. It doesn't seem to detach the powder coat in any way. That steel seems to stay adhered. So let's ream that out very gently. I think you do have to take some of the, oh, I'm going quite aggressively in there, some of the aluminium away. It's not just a case of removing the powder coat plastic. And oh, that still doesn't quite fit. A little bit more then. Okay, how does that fit? Oh, that's a beautiful fit. Yeah, that fits through there lovely. Good, that's fully reamed. Yeah, actually I do need to ream the inside of this out a bit, because although it fits over the threads, it doesn't sit on the sort of shelf, what would you call it, on there. So just going to open that out a little bit on the inside with the reamer. Yeah, the light level keeps changing. It's one of those days where the sun keeps going behind clouds and then coming out again. And really I should change the settings of my blinds, but you can't do that when the sun is going in and out every 5 minutes. It's quite difficult to ream this because I'm trying to hold this washer, but the blades, and they're quite sharp, are sort of snatching at my fingers as I do it. So it is pretty tricky. Yeah, the whole back illumination thing, it gives a nice sort of style to my photography, but it can be a real nuisance when the sun is going out. The feng shui of this room is all wrong. Or should I say, feng shui. Somebody said get a box spanner for these nuts the other day. Well, as luck would have it, I've got one. It's the wrong size. This is 8, 9, and this is 10. So, sorry. Back to my open-ended spanner. So now that this is mounted on the back of the front panel, the nuts are done up on the front, I can now just touch some of these pins with my soldering iron to get the alignment point. You can see it's not completely flat on the board. And then I can dismantle it all and finish soldering that. But it's a bit tricky to get to, so it's going to have to be done off camera. Yeah, it's really tricky soldering right in there with this great big panel in my way. Okay, so this whole lot now has to come off. I think that one's finger tight. Yep, and let's get these 3 off and then I can finish that soldering. Now I've slightly changed the camera angle for this shot. I hope you like it. It's much less from the top and much more from the front, but yes, I can get to these quite easily now. It might be slight, they're not the best joints because my access is not very good. The one under there is going to be a little bit more difficult. In fact, I think that's going to have to be sat up on something. How about this little tub of, well, lead essentially. Most of my lead offcuts. Oh, that's really difficult to get to. I think that IC is going to have to come out. I can't get to it. Can I get to that now? Yeah, still not easy. But do my best. Yeah, I think that one's got it. It's not the best joint. But it's not going to be the best joint when access is so... I think I'm touching the plastic of this socket and melting it. Access to this is really quite difficult. That's not bad. It's good enough. And that sort of completes my output mixer amplifier. Yes, I've got my socket arrays to go on the back here. So that would be that one. And I need to put the pins into these, but I seem to remember there were complications in doing that. I might even watch my own video back to remind myself how I did it. But that's getting very close to being finished. Let's put that chip back in. That's the 741 op amp. Get rid of my tub of lead. It's kind of the dregs of the solder when it gets very short. Yeah, it's a beautiful thing. So here we go. That's now the distance between those two. The socket and the pot is now fixed because I've soldered that pin array. So is it going to be an exquisite fit when I drop this in there? Oh yeah. That is so satisfying, don't you think? It's a perfect fit. And it's even more perfect that these pots, there's a bit of rotation alignment, but they should sit approximately centrally in their holes. That's what I like. And now the front panel is starting to look like something because we've got one of the input amplifiers here, the output amplifier now over here. There is another input amplifier. It's the same as this one, and it goes there. The slew rate board goes there. And now here, this is the big one. This is the excitation board. And I've just finished designing that. Would you like to have a look at it? And I often complain about how tiny my workshop is. Well, you can see here, it's a total mess. Floor to ceiling. There's the ceiling. Back down to the floor. And yes, after a build like this, the place is a shambles. So here's the schematic for the excitation board. And yes, I only just managed to cram all this on one sheet in the schematic section of Easy EDA. I've had to stretch this out so that you can see what's going on at all. There's a lot going on there. There's a lot of op amps. There's two oscillators. There's a mixer. There's a rectifier. There's a smoother. There's a transconductance op amp. There's something measuring stuff coming out of the filters. There's a comparator. There's some transistorized circuitry here. There's an analog switch, a 4016. And then there are two digital chips, CMOS chips, which are the linear feedback shift register of the noise generator, the only digital part of this system. Right, let's go to the PCB. And this is the PCB layout. And yes, it's a pretty condensed PCB layout. Once again, the width of this board is pretty much defined by the pots down here and the spacing between them. And so, yes, it took a while to cram all this on there. Let's take off the top silk. There's very little on the bottom silk, so I'll leave that on. Let's take off, well, let's go to the bottom layer. That's mostly power, although there are a few signal tracks on there where I couldn't put them on the top. But yeah, I tried to put most of the signaling stuff on the top. Let's put the top silk back on. That's going to be a really nice board when I get it shipped off and manufactured and it comes back. Looking forward to that one. Oh, I didn't really explain the reason that alternate channels are inverted with respect to their near neighbors. Well, I'm going to have to do that in another video now because there isn't really time in this one. But this arrangement of sockets, because these 8 input, well, there are 16, there are 14 channels in the vocoder, but I've got the potential for 16 inputs because there are 8 per daughter board here. This gives me an opportunity to not follow this arrangement of alternating the channels, just to see what the effect would be, because this acts as a little patch bay, so I can patch these inputs to different combinations of filter channels and just see what the effect is. So it's one of the reasons I went for this idea. It just gives me more flexibility to play in my analog playground. Anyway, I think that's enough for this board. I'm going to finish this off in my own time. So for the moment, cheerio.